Hello everyone, let us solve today's GfG problem of the day, and the problem name is not a subset sum. So let us read the problem statement. So you are given a sorted array ARR of positive integers, and we need to find the smallest positive integer such that it cannot be represented as the sum of elements of any of the subsets in the given array set. So let us understand this question, what the question is saying, and try to find some solution out of it. So let us understand what the question is saying. So let us say we are given this array. So they are saying that we need to find the smallest positive integer that cannot be represented at the subset sum. So what is the subset sum? So subset sum is like, let me show you, one individual element can be represented at sum itself. Again 2 and 3 can be represented at sum itself. There can be combination of 1 and 2, so 1 comma 2 can be one another subset, 1 comma 3 can be another, 2 comma 3 can be another, and 1 comma 2 comma 3 can another be a subset. So these all are these subset. Now what is subset sum? The summation of the elements of the subset. So in this case it will be 1, in this case it will be 2, in this case it will be 3. In this case again it will be 3, in this case it will be 4, in this case it will be 5, and in this case it will be 6. So we need to find the smallest positive integer which cannot be represented as the subset sum. So you can observe 1 is present, 2 is present, 3 is present, 4 is present, 5 is present, 6 is present. So what can be the smallest positive integer which cannot be represented as the subset sum in this array? Obviously 7, because 7 is not available, so we need to return 7. So this is what the question is saying. Now there is one more information given in the question, that the given array is sorted. So we need to make use of this information. This information will help us to solve this question. So let us see how will we solve this question. So what can we do? We can assume our initial assumption to be 1. So what we can do, we will assume that smallest positive integer which cannot be represented as the subset sum is 1. Now why 1? So let me give you another scenario. Let us say we are given this array 6, 7 and 8. So we will check with the first number. So we can observe that ARR of I is greater than our current answer. Now if this is the case, if ARR of I is greater than our current answer, then obviously this number cannot be generated. So we just need to return answer. So this current answer will be our smallest positive integer. So this is one scenario. So what is the another scenario? Another scenario is let me write here. So if ARR of I is less than or equal to answer. So this is another scenario which is remaining. So what we will do in this case? So let me give you another example, and with the help of that we will see what we can do in this scenario. So let me just erase this. So yeah, let us assume we are given one array, and in between, let's say we have one element 5, and before that there are some element, after that there are some element, and till now we have computed the subset sum till here, and our current answer or our current assumption is 5. So we come across this 5 and we can see that ARR of I is less than equal to our current answer. So we will hit this condition. So what we will do now? Now what does this answer indicate? So let us first understand that. Now this answer indicate that till now we can generate 1, till now we can generate 2, till now we can generate 3, as well as till now we can generate 4 as our subset sum till here. So till here we can generate these 4 sum. So what can be the next possible sum which we cannot generate? So how will we find out? Now here comes the sorted array part. Now we all know that till now the array is sorted. So these elements would be obviously lesser than 5. So what we can do? We can just add this 5 with 1. So what can be the next number? It is 6. We can add this 5 with 2. What we will get? We will get 7. We will add this 5 with 3. We can get 8. We can add this 5 with 4. We can get 9. So you can see that if we add 5 with 1, 2, 3 and 4, we can get this 6 number as well, we can get the 7 number as well, we can get 8 number as well, also we can get number 9 as well. So what does that indicate? It indicates we can generate 1 as well, 2 as well, 3 as well and 4 as well with the help of this indication of our answer. But also we can now also generate number 6, 7, 8, 9 as well as 5 also, because 5 is already there. So what can be the next possible number? Obviously 10. So we just need to check now. Instead of checking 6, 7, 8, 9, we can directly jump onto 10 to find whether it can be made or not. So how did we find out this 10? So if we observe this carefully, this 10 is nothing but answer equal to answer plus ARR of I. So what will be the answer? Answer is currently 5, and what is ARR of I? ARR of I is also 5. So our new answer or new possibility will now become 10. So in the case of if ARR of I is less than or equal to our answer, we just need to update our answer to be answer equal to answer plus ARR of I. And the other scenario we have already discussed. So this was it about the question, and this might not be very intuitive to understand, but if you take some example and dry run on that, you'll able to understand how this logic is working. So hope you understood these two scenarios, and this was it about the question. So let us directly write the code now. So let us write the code now. So initially we will maintain one answer variable which we need to return. Initially we will assume it to be 1. Then we will make one new variable which will tell us the size of the ARR array, and now we just need to iterate over the entire array. And what we have seen in the explanation, we just need to check two conditions. If ARR of I is greater than our current answer, else if it is lesser than or equal to, so what we need to do in that case. So if ARR of I is greater than our answer, that means we just need to return our answer. Otherwise, we just need to update our answer equal to answer plus ARR of I. And in the end, we can just return this answer. So this was it about the code. So let us see if this gets accepted or not. So yeah, our code got accepted. So hope you learned from this video. Thank you.